To have good chances of seeing northern lights in Europe, one must be far up in the north, preferably near the Arctic Circle. When foreign tourists look for information about Sweden, Norway and Finland, northern lights pops up at the top with local variations for each country. In Sweden, it's the northern lights, skiing and hiking. In Norway, it's the northern lights, fjords and glaciers. And in Finland, it's the northern lights, sauna and igloo. The world's first igloo for Aurora viewing was built in Finland in Saariselkä in 2001, but now the concept has spread and glass igloos can be found all over the world, and not only for Aurora viewing. And it's an increasingly popular accommodation option according to Global Glass Igloos Market Research Report 2023. Of course, one doesn't need to pay to stay overnight in a glass igloo to see the northern lights, but it's a comfortable option because it's an activity for the dark, cold winter nights. The northern lights actually exist all year round, even in the summer, but it must be dark to see them, which doesn't work during the summertime because up here in the north the sun never sets and it's too bright between May and September. But from September onward, it's a good time to spot them. So then, what are the northern lights and why and when do they show up? The northern lights occur when Earth's magnetic field is hit by high-speed solar wind streams that accelerate electrons in Earth's magnetosphere and channels them at high speed towards the poles where they collide with atoms in the upper atmosphere called the ionosphere. This collision transforms kinetic energy into visible light. The ionosphere starts from 80 kilometers upward without a distinct upper limit, but somewhere between 500 and 2000 kilometers. Depending on how far down in the ionosphere the particles manage to reach before they collide and with what force, the northern lights form in different colors. Different layers of the ionosphere consist of different substances. At an altitude of 80 kilometers, the northern lights turn bluish-violet when particles collide with nitrogen. Above 110 kilometers, they turn green when atomic oxygen is excited to the singlet S state, and at an altitude about 250 kilometers, atomic oxygen is excited to the singlet D state, creating red lights. The different singlet states has to do with orbital angular momentum quantum numbers, but my knowledge of physics is unfortunately not enough to either understand or explain what that means. And I couldn't understand the explanations that I found on the internet either. We perceive the bluish-violet light immediately, followed by the green after approximately 0.7 seconds, and the red light becomes visible around 2 minutes after the collision. This delay occurs because different atoms retain photons for varying durations before emitting them. Why can't we see northern lights every night? It all depends on the sun's activity. It needs to eject enough particles with sufficient speed in the direction of the Earth, and the polarity in the wave must be in the right direction when it reaches Earth's magnetic field. It's like two magnets. They either attract or repel each other. Even if everything is set for a perfect storm, if it's cloudy, we won't see anything. Furthermore, the sun's activity goes up and down in 11-year cycles on average, and not all years are equally good. We are now in cycle 25, and the solar maximum is expected to occur between 2023 and 2026. The forecast for the northern lights is thus very good in the coming years before it begins to decline again. There are many different apps available for northern lights forecast. This one is called My Aurora Forecast. A good combination of values to look for. Solar wind speed 400 meters per second or more. Solar wind density 4 parts per cubic centimeter or more. The north-south direction of the interplanetary magnetic field be set -10 nanotesla or less, and the strength of the interplanetary magnetic field 18 nanotesla or more. The direction of the magnetic field is the most important parameter, followed by solar wind speed and strength of the magnetic field. The KP index shows how far south you can expect to see northern lights and how strong they are. To expect to see at least some decent auroras in northern Scandinavia, KP 3 or higher is good. When the KP is 5, they are much stronger and you can expect to see northern lights 1000 kilometers further south in Stockholm, and when it reaches the maximum level of 9, you could maybe see northern lights all the way down in Barcelona. How frequently can one expect to witness highly intense auroras? A solar cycle is 11 years, and during that time, you can expect northern lights that reach KP 5 1700 times, KP 6 600 times, KP 7 200 times, KP 8 100 times, and finally KP 9 4 times. The strongest auroras I have observed in recent years, as confirmed by my app, have been around KP 6 or 7. The so-called Aurora oval, a donut-shaped ring where northern lights are visible, revolve around the North Geomagnetic Pole, which is centered above Ellesmere Island in Canada, about 10 degrees south from the geographic North Pole, and it means that northern lights can be seen further south in North America compared with northern Scandinavia. Also, don't confuse geomagnetic pole with magnetic pole.
No, pero da igual, se veía que vemos un espectáculo, es mejor. Mira, ver cómo es verde. Nosotras solas. Era ya lista a decir, sí, ha sido perfecto, pero las auroras, saben, no las hemos vistas como quería, pero no importa. El mundo del mundo vas a ver, ¿sabes? Y espérate que también